In this video, we will go through the history of mathematics in India. Like we have seen in the introduction to Ganitha, we learn in our textbooks that the contribution of India to mathematics is zero. We saw in brief what this country contributed to the number system and how it was transmitted to Arabic world in the introduction to Ganitha. We shall see now what else Indian did in this field. Try to identify some of these pictures that you will find in books and internet. If you can identify at least 5 of them, you know good enough to understand what this country gave to mathematics. If not, watching this video is worth your time. Both for students who have not yet learned and those who have completed the education without knowing what Bharata gave to maths. What is coming in subsequent slides is some serious stuff. I have already learned few lies in my textbook so far, and I would like to unlearn some of those. To introduce the people and to put a face to the name, starting from the picture from top left: Brahmagupta, Pingala, Lagada, Bhaskaracharya, Aryabhata, Hemachandra, Gargamuni, Baudhayana, Madhava, Varahamira, Bhaskara, Mahaviracharya. Let us learn about the history of mathematics in India: why, when, and who. Let us go back in time to look at the prehistoric times as we learn in textbook. Stone Age has 3 periods. From 2 million years ago to maybe 8000 BC, it is split into 3 ages: Paleolithic, Mesolithic, and Neolithic. It is the Mesolithic period when agriculture started in the Fertile Crescent. Bronze Age was in 3500 BCE to 1500 BCE, and Iron Age was after 1000 BCE. Are these statements true? Not anymore, because we know for sure with archaeological evidences that Iron Age predated 2000 BC, as there are iron smelting furnaces found in the plains of Ganga. Either they lied about the Indian context or they hid the information intentionally. Thanks to Dr. Anil Suri for the information below. India did not see an ice age, which is why civilization flourished in the subcontinent. India saw rivers from the Ice Age like Saraswati. Oldest Rigvedic mantras talk about mighty Saraswati. Grassland appeared in the south, making it suitable for agriculture. In Sri Lanka, 45,000-year-old remains of minerals from cereals were found. Hoarded agriculture produce. In Papua New Guinea, 52,000-year-old remains of proof of agriculture were found. In Ganga Plains, grasslands were formed by at least 17,000 from before present, whereas grasslands in Fertile Crescent appeared after 10,000 years from before present. Jwalapura is a site in Andhra Pradesh where 75,000-year-old artifacts were found, which disprove the theory of Mesopotamia being the cradle of agriculture. So, why are we talking about agriculture and other fields in the history of Ganitha? Just like the others, there is a lot of misinformation in the field of mathematics as well, and they are all interlinked. We shall find out the history of Ganitha in Indian context. It is a popular narrative that Ganitha include Rajya Ganitha or Shulpa Sutra came into existence for creation of Vedic altars. Is it true? Yes, it is. Is it completely truth? Again, not entirely. Why Bharatavarsha needed mathematics? Reason 1. Bharata was dependent on agriculture. Agriculture depends on monsoons and seasons. To predict monsoon and season, one needs an accurate calendar. Panchanga or Hindu calendar system came into existence, and reading the Panchanga was made everyday practice in the Hindu rituals. Accuracy of Panchanga completely depends on the maturity in the mathematics. Reason 2. Indian Ocean was a big trade route from antiquity. Trade routes to Africa, Alexandria and Egypt was a busy route. South China Sea, Southeast Asia was well connected to Indian coastal ports. Indian merchants had the biggest ships in the world. Astronomy and calendar helped to determine season, masa, paksha, tithi, nakshatra, samaya, which were most important to navigate in the sea, along with accurate calculations of longitude and latitude. When Hindu traders guided Vasco da Gama from Africa to Gujarat, Obviously, because he did not know navigation. Hindu merchant ships were much bigger than his ship, even though he had the biggest ship in all of Europe. It is laughable that we all learned that Vasco da Gama discovered India. Reason 3. Building cities require proper planning like measurements of land, for water channels, constructions. Shapes and geometry are handy when it comes to civil engineering. Hindu architecture or Vastu Shastra was handy in the building some of the oldest cities in the world. Cities which give moksha, Kashi from unknown times, Ayodhya more than 15,000 years old, to recent cities like Kanchi and Banavasi, which were around 2,500 years old, were all perfectly planned. I could handpick 20 cities and their approximate age to give a glimpse of ancient Indian architectural marvel. We can see such constructions in our temples even today, which are made to perfection. So, where did Ganitha come from in Bharata? Let us look at some of these texts and their authors who were astronomers and mathematicians. Surya Siddhanta is one of the oldest surviving astronomical texts. It was given to Maya by Surya himself and hence the name. The scale on the left gives evidence of updates which happened to this text from time to time due to correction needed in the astronomical data. The text contains all astronomical sutras which contain rich mathematical knowledge from antiquity. There are other Siddhantas of antiquity. 18 such Siddhantas are given here from Paitamaha Siddhanta to Parashara during Mahabharata times. Authors of these texts were our ancient rishis after whom they were named. All Saptarishis' name can be found here. These rishis were not just religious saints but scientists and head of Hindu educational institutes called Gurukulas. In the ancient time, they invented new things. They taught the people about skills required to survive and develop. They ensured peace, prosperity, and morality in the society. All these Siddhantas are more than 7,000 years old. Lagada wrote Vedanga Jyotisha, which is an astronomical treatise. Lagada, as per some claims, existed before Ramayana times. Vedanga Jyotisha was edited by Shuchi around 3500 years ago. This text say, just like the crest of peacock, gem on the head of a serpent, Ganitha is to the Vedanga Shastras. That is the importance given to the mathematics in Hindu culture. There are 8 Shulba Sutras. Shulba Sutra contain mathematics related to geometry. Their primary purpose was creation of Vedic altars, but geometry has other applications as well, like astronomy, navigation, architecture. Mathematics is not Greek in origin, like what is attributed to Euclid and Pythagoras, but very much Indian. Read the works of C.K. Raju and other to understand how the Greek myth was created. This slide may surprise many. Yes, there were 3 Aryabhatas. Maha was junior contemporary of Parashara Rishi, who was father of Vedavyasa. He wrote Maha-Aryabhata Siddhanta. Aryabhata too was 23-year-old when he wrote Aryabhatiyam, when 360 or 3600 years passed after third yuga, which is approximately 4000 to 4500 year old. It is not 400 CE as told by school textbook. Aryabhatta III recompiled Maha-Aryabhatta Siddhanta probably 1600 years ago. This is the person who our school books refer but wrongly attribute Aryabhatiya to him. Aryabhatiya is one of the prominent texts of astronomy surviving today. It is Ganithapada and Golapada which provide sutras covering arithmetic, algebra, and geometry. Highlighted in red are the specific works related to mathematics. Aryabhatta too calculated the size of Earth to 0.27% of accuracy to the current value. He gave value of pi to accuracy of 4 decimals. The first sign tables were provided by Aryabhatta, and yes, names for 7 days in a week with specific reason was given by Aryabhatta. Varahamira is the celebrated astronomer and polymath from the court of Vikramaditya. He is believed to be the person behind the so-called Qutub Minar, which was Vishnu Stamba constructed for astronomical purposes. In his work, he improved sine tables of Aryabhatta, gave magic square, and what later came to be known as Pascal's triangle. Brahmagupta authored the famous Brahmasputa Siddhanta theoretical book and then Khandakhadyaka, a practical treatise. These were translated by Al-Fazari and then by Al-Khwarizmi partially to Arabic 8 centuries later, which led to claim of Arabs inventing arithmetics and algebra. In this book, he mentions he wrote this book in Shaka 550, mostly 33 to 32 BCE. He gave very high importance to zero and made specific rules of computations with zero. He touched on negative numbers, solutions to linear and quadratic equations. His Brahmagupta series is now called as Fibonacci series. The Siddhanta gives square roots and cube roots, sum of squares and cubes, rules for fraction, sine tables, pi, famous Brahmagupta theorem of trapezoid, rational triangle, cyclic quadrilaterals. Bhaskara I wrote Laghu Bhaskariya and Mahabhaskariya. He used current form of Hindu decimal system, though he did not invent it. He also gave refined sine table value of pi as 22 by 7, improved sine tables, worked on prime numbers. His work is now known as Wilson's theorem. Bhaskaracharya or Bhaskara II is most likely existed before Bhaskara I. The confusion arose due to the Shaka era that was assumed in his timeline calculation, that is Shalivana Shaka 78 CE instead of Shaka era 583 BCE or earlier. He was born mostly in 452-453 CE. He was the head of Ujjain Observatory. His Siddhanta Shiromani touched every aspect of mathematics, from arithmetic, algebra, geometry, calculus. Yes, he is the inventor of calculus, not Newton, not Leibniz. Part of this treatise, Leelavati, named after his daughter, was used in every gurukulas to teach students until the Indian educational system was destroyed by the British. Some of the other notable mathematicians before the Islamic world was exposed to the Indian knowledge and the specific contributions are Sridhara, who worked on numerous areas of Ganitha or mathematics on slate. His work is also known as Trishatika, as contained 300 shlokas on numerous operations on numbers, business and partnership, geometry and mensuration. Pingala, who gave Pascal's triangle, Fibonacci series, and binary system with 0 and 1. Yatishvara gave concept of infinity. Hemachandra worked on Fibonacci series. Mahavira worked on permutation and combinations, cubic equations, sum of unit fractions. This is not everything about what Bharata contributed to Ganitha, but just an overview of what happened much before Arabic world opened its eyes to the world of knowledge, and Europe was not even born in terms of knowledge. There is much more which came in the next 1500 years, and many more amazing mathematicians. I'm curious to learn them as I grow up. Let us be proud about the contribution to mathematics by India, which is just not zero but much more.